Hi everybody. In this video we are going to be using probability as a way to determine the outcome of a conditional statement. So the code I have right here is just a very simple drum beat. I have two live loops, one which has a kick and a snare, and one which has a hi-hat, and it just sounds like this. So what I'm going to do is I'm going to add a if statement, and that is going to determine what kind of snare drum I have. So I'm just going to say if. I'm going to leave that condition open right now, but if that condition evaluates as true, we're going to use this dolph snare, else we're going to use the generic snare. So that is what's going to happen, and you can hear if we evaluate this as true. But if it's false, so I've chosen those two snare drum sounds just because they sound pretty different. It's easy to tell the difference between one and the other. So what we want to do here is, for this condition in our conditional statement, we want it to have a certain probability that will evaluate true or evaluate false, and we can kind of control the probability so we have an idea of what the odds are going to be that it's going to evaluate true or evaluate false. So the first one we're going to do is something called 1_in. And this takes one argument that we can pass to it. So I'm going to do 1_3. And basically this does exactly what it sounds like it does. So there is a 1_3 chance that this will evaluate as true. And if it does evaluate or as true, then this is going to play. If not, then this is going to play. So basically I'm saying that there's a 1_3 chance that it's going to play this sound, otherwise it's going to play this sound. Since we are going to be running a few of these, I'm also going to just do a use random seed so we don't get the same thing every time, and I'm going to try and make a true randomness here as close to it as I can get by using time.now.to_i. So this is a way that we can have a bit more true randomness to how our code generates random numbers. I did do a tutorial on this, so pseudo randomness versus true randomness, which you can watch, and that just goes over how Sonic Pi kind of works under the hood in terms of its random number generation. But this is going to give us at least different results every time we run it. So if I run it now, so there you heard it. So more often we got the generic because there was a 2/3 chance that that's what we were going to get, and then there was 1_3 chance we were going to get this. Now I could change this number here to say maybe I want 1_8. So there's a 1_8 chance, so that would statistically reduce the odds that I'm going to get this and increase the odds that I was going to get this, so I could run it. So we have that. Now, if I wanted to flip this, if I wanted to have this be more often than this, I could obviously just switch these, but I could also just add the exclamation point, so not 1_8. So this would basically reverse that. We'd have a 7/8 chance that we get this, and a 1/8 chance that we get this. So in that example you hear we got the dolph a lot more than we got the generic. So that's how this 1_in function works and just returns either true or false depending on the number you give there. But that really just kind of limits us to it's either a 1 in 8 chance or a 7 in 8 chance or a 1 in whatever chance and then n minus 1 chance of the other. But it doesn't really give us the opportunity to kind of customize a bit more in terms of how we want to do that. So another way we can add probability is by using a data structure called a nit. So a nit, and I'm going to store that in this variable called k, like this. The way a nit works is that you have to pass 2 arguments at a time. The first argument is the value you want, and the second argument is how many times you want that value to happen. So in this case, I'm going to have true, and let's say I want true to happen 7 times, and then I'm going to do false as my next one, and I want false to happen 3 times. Now, just so we can see, I'm going to put k into the log here. So if I jump back, you see here it outputs a ring, and here I have 1, 2, 3, 4, 5, 6, 7 trues and 1, 2, 3 false, which is exactly what I specified to happen here. So that's how the nit data structure works, and now what I can do is I can put as the condition in my conditional statement k dot choose, and this will now select randomly from this ring either a true or a false, and statistically there is a 70% chance that we're going to get a true and a 30% chance that we're going to get a false, in which case 70% chance for this one, 30% chance for this one. So that sounds about right. We certainly heard a few more of the dolphs than we did of the generics. But the nice thing about this method is you can really kind of customize the exact amount of probability. I'm kind of doing things within out of 10. I could do it out of 100, so I could do, maybe I want a 74% chance that it's going to be true, and then a 26% chance that it's going to be false. So slightly less than 3 out of 4. And that's the basic idea. And it doesn't have to be out of 10, it doesn't have to be at 100. I could say, just do something like I want to do 132, and then I want to do 87, or something like that. You could really fine tune the probability here to whatever you want. And this is getting a little excessive here, but just to kind of make the point that you could really do whatever you want. So if you're making generative music and you really want it to be random but want to have some control over the probability of when one thing might happen over the other, you can use either of these methods, the one in, or you can use a nit and just kind of fine tune exactly what the probability of either outcome would be. And that is a way you can incorporate some probability and randomness into your musical projects.